In a triangle ABC, students, let us discuss about the length of the medians through A, length through B, through C in a triangle ABC. So, in a triangle ABC, the length of the median through A is AD is equal to half into square root of 2b square to c square minus a square, where D is midpoint of BC. Midpoint of BC. Right. Now coming this one is, let AB bar is equal to B bar, AC bar is equal to C bar, be the sides of triangle ABC, where A is the origin. A is the origin, where A is the origin. Now, by definition or by vector addition or by definition of median, the median AD bar can be decomposed as sum of these two sides by 2, or by vector addition also you can go for this. By definition, AD bar is equal to AB bar plus AC bar by 2. AC bar by 2. Cross multiply 2, we are given with AB bar plus AC bar. Then squaring on both sides, or else 2 into AD bar. What I do is, before squaring, 2 times of AD bar, B bar plus C bar, wait, if I take this as B bar, if I take this as C bar, angle between B bar and C bar is equal to A. Squaring on both sides, squaring on both sides, 4 into is equal to B bar square C bar square. As you know already, modulus of B bar plus C bar whole square is same as B bar plus C bar whole square. I can write this is 2 into B bar dot C bar. So therefore, by definition, or else since A bar dot A is equal to mod A whole square is equal to A square or A bar square, as you please. Now I can write 4 into AD bar square is equal to B square This is C square by definition mod, that is mod B into mod C into cos A. A is the angle between B bar and C bar. So therefore 4 into AD bar square is equal to B square C square. 2BC is same as A square. Any modulus, we know that modulus of A bar is nothing but just A. That represents the length of the side. So therefore, cos A, we know according to the cosine rule, in a triangle ABC, cos A can be written as B square plus C square minus A square by 2BC. These and these get cancels. Therefore, I can write 4 into AD bar square is equal to B bar square C bar square plus B bar square C bar square minus A square. Now, I can write 4 into AD bar square is equal to, yes, come on, 2 into B square, 2 into C square minus A square. So therefore, now I can write AD bar square is equal to 4 into bracket 2B square 2C square minus A square, which implies AD is equal to, yes, come on, 1 by 2 into square root of 2B square 2C square minus A square. Remember? Now, this is the what? The length of the median through A. Length of the median through. Once again, in a triangle ABC, take A as the origin. Let AB bar is equal to B bar, AC bar is equal to C bar, be two vectors representing the two sides. And angle between them is what? A. So therefore, now by using the median property, yes, AD bar is equal to AB bar plus AC bar by 2. Cross multiply. Then 2 into AD bar. AB bar is equal to B bar. AC bar is equal to C bar. Angle between them is what? A. Squaring on both sides. I got it. B dot C. It's what? Cos A. But cosine rule, we know that B square plus C square minus A square by 2BC. This is what? B square plus C square plus B square plus C square. These two get cancels, A square. By adding them, we have arrived at the median through A. F into square root of 2B square plus 2C square minus A square. Opposite to A, minus A square. Opposite to B, minus B square. Opposite to C, minus C square. So therefore, this is the length of the median through A. Let us see length of the median through B. Now, if I go to this one is, yes. Now similarly, length of the median through second one B is BE is equal to half into square root of 2A square 2C square minus B square. Then third one is C through C is CF is equal to half into square root of 2, that is 2a square, 2b square minus c square. These are the lengths of the medians through A, through B, through C. Followed? Now, vector equation of a plane. Yes, already you come across about the planes in addition of vectors. As what? The first one is the vector equation of a plane passing through the point A bar and parallel to the vectors B bar and C bar is given by R bar is equal to A bar plus SB bar plus TC bar. Meanwhile, the vector equation of a plane passing through 2 points A bar and B bar and parallel to vector C bar is R bar is equal to 1 minus S into A bar plus SB bar plus TC bar. The vector equation of a plane passing through 3 non-collinear points A bar, B bar, C bar is given by R bar is equal to 1 minus S minus T into A bar plus SB bar plus TC bar. All those discussion we had in the addition of vectors. As we have dealt on all those equations in addition of vectors of planes, now let us discuss about the vector equation of a plane by using the definition of dot or a scalar product of vectors. Now what I do is, what the theorem says, the theorem says let P greater than 0 be the perpendicular distance from the origin to the plane and n cap be the unit vector perpendicular to the plane then R bar dot n cap is equal to P. R bar dot n cap is equal to P. R bar dot n cap is equal to P. So therefore, what I do is, this is a plane. Now this is the origin. This is P be the point in a plane whose position vector is R bar. Now take this is a plane. For this plane, this is the n cap perpendicular to the plane. Let it meets the plane at a point n. That point I take it as n. Followed. This is a plane. Now this, let it meet the plane at this point N. I cannot show like this. I have to write because it's a 3D plane. The perception left to the student understand. He has to think more. So therefore, now what I do is, this is the vector perpendicular to the plane. Let it meet the plane at a point N. Look here, so far we have found out the angle between the two vectors, but we haven't found out the angle between a point and a vector. This is the situation where we are finding the what? Angle between a point and a vector. But point we are converting later it as a vector. So therefore, let it be, this is nothing but a theta. Construct the triangle OPN. Construct a triangle OPN where the length of this is P. Sir, you are writing that ON as N cap. If you take this length as a what? 1 you are getting. But then how do you write P? You have to understand. Anyhow it is perpendicular. Let it be length is what? P. Assume that. Instead of drawing separate line. Followed? So therefore, now if you take in terms of unit vector, its modulus is 1. I do admit, I am not denying it. But in 3D, if you go for more number of lines, more ambiguity, more complexity, and it will not convincing to understand. So therefore, now let it be this length is what? ON is what? P. Okay. So maybe N cap is collinear with ON. So therefore, now I am going to start. The proof of this one is very simple. Let P be a point in the plane, and OP bar is equal to R bar be the position vector of P, where O is the origin. O is the origin. And N be the point where the perpendicular, where N cap meets the plane, and N cap is perpendicular to the plane. N cap is the what? Unit vector is perpendicular to the plane such that is equal to P. Right? From triangle OPN, I am going to write cos theta. Cos theta is equal to adjacent side by hypotenuse, ON by OP. Therefore, ON is nothing but OP into cos theta. What is this? P. This is nothing but modulus of r bar into 1 into what? Theta is the angle between OP bar and n cap. Am I correct? Why? Because theta is the angle between these two vectors. Henceforth, I have taken it as what? Theta. So therefore, this 1 I want to put as a modulus of n cap. Followed. This is the logic. In very less number of books, you find the proof of this one is, they go in a different way. But if you know in a skillful, if you know the logic, you can complete this proof. So therefore, now this 1, I take it, 1 into anything is what? Same thing. That is understood. That goes without saying. Therefore, this 1, I am taking it as what? Modulus of n cap. Modulus of n cap. So therefore, P is equal to modulus of r bar into modulus of n cap into cos theta. Theta is the angle between what? R bar and n cap. Therefore, by using the definition of dot product, I can write P is equal to R bar dot n cap. This represents the vector equation of a plane. The equation of a plane where n cap is the unit vector perpendicular to the plane and P be the what? Perpendicular distance from the origin to the plane can be written as the dot product of R and N, R bar dot n cap is equal to P. Look here. Now from this figure, once again it's a very typical proof, try to understand. Let O be the origin, P be the point, general point in a plane, we have to represent through P. And N be the point in the plane where the n cap is meeting the plane. That meeting point is nothing but N. So therefore, now n cap is perpendicular to the plane. You can very well observe and take this distance as what? Perpendicular distance P. So therefore, OP bar be the position vector of a P where O is the origin and N be the point where n cap meets the plane and n cap is perpendicular to the plane such that Yn is equal to what? P. From the triangle, cos theta is equal to Yn by OP. ON is equal to OP into cos theta. OP is modulus of R bar. Here 1, that goes without saying. One must understand the logic here. 1 into cos theta. Theta is the angle between OP bar and n cap. Therefore, we can take this as what? R bar dot n cap. That's a vector equation of a plane. Now, note the Cartesian equation of a plane just now you come across about the vector equation of a plane. Now the Cartesian equation of a plane, what it is, instead of representing it as what? R bar dot n cap is equal to P, let us represent in terms of x, y, z. Let R bar is equal to xi plus yj plus zk represents the point with respect to orthogonal coordinate axis P, and L, M, N be the DCS of the unit vector n cap. Yes, since the vector equation of a plane is r bar dot n cap is equal to p. R bar dot n cap is equal to p. So therefore, what I do is, r bar is what? Xi, Yj, Zk dot Li, Mj, Nk is equal to p. In place of n cap, I have taken Li plus Mj plus Nk. What's the modulus of Li plus Mj plus Nk? Modulus is 1, since Lmn are the DCS of a vector. We know that when Lmn are the DCS of a vector, L square plus M square plus N square is equal to what? 1. L square plus M square plus N square is equal to 1. So therefore, now Li plus Mj plus Nk is equal to what? P. Take the dot product. We know that already I dot I, J dot J, K dot K is equal to 1. I dot J, J dot K, K dot I is equal to 0. With the help of that, and also I told, if A bar is equal to A1I plus A2J plus A3K, B bar is equal to B1I plus B2J plus B3K, we know that A bar dot B bar without giving a what angle, I told, we discussed already, A bar dot B bar is equal to A1 B1 plus A2 B2 plus A3 plus B3. Okay, A3 plus B3. So therefore, you take the dot product. Yes, Lx plus My plus Nz is equal to P. Now is the Cartesian equation of a plane. Cartesian equation of a plane. Now if I take, I told just now, this is n, note, when or else when the plane passes through the origin, then P is equal to 0. Perpendicular distance is 0. This plane is passing, this one is no perpendicular distance, because this will coincide. P is equal to 0. Then P is equal to 0. Then vector equation of a plane passing through the through the origin and n cap is the unit vector is r bar dot n cap is equal to 0. R bar dot n cap is equal to 0. So therefore, r bar dot n cap is equal to 0. Now, whenever any plane is passing through origin, then the perpendicular distance from the origin will be 0. So that the vector equation of plane, which in the form of r bar dot n cap is equal to p, will become as what? R bar dot n cap is equal to what? 0. That is, if I take, if r bar is equal to xi plus yj zk and n cap is equal to li mj plus nk, then Cartesian equation of plane is r bar dot n cap is equal to 0. Take the dot product. Lx plus my. This is a vector equation of a plane passing through the origin and perpendicular to n cap. This is Cartesian equation of a plane perpendicular to n cap and passing through origin. Passing through origin is given by Lx plus my plus nz is equal to 0. And meanwhile, this is r bar dot n cap is equal to what? 0. R bar dot n cap is equal to 0. Now, the another theorem. The theorem is vector equation of a plane passing through the point a bar and perpendicular to the unit vector n cap is r bar minus a bar n cap is equal to 0. Look here. So now this is what vector equation of a plane passing through the point a bar and perpendicular to the unit vector n cap. Earlier we have discussed the vector equation of a plane perpendicular to n cap and p be the perpendicular distance from the origin is given by r bar dot n cap is equal to p. This is passing through the point a bar and perpendicular to n cap is given by r bar minus a bar dot n cap is equal to 0. If I take this a plane This is the origin. Now, this is a plane. This plane is passing through 2 points. This is AP bar. This vector is AP bar. For this plane may contain one vector or two vectors or three vectors. Let it be any number of vectors it may contain. If this is the n cap is the unit vector perpendicular to this plane, this is also perpendicular to each and every vector present in that plane. Followed? Now let us start. How the what? Come on. This can be NV says, right? Let OA bar is equal to A bar, OP bar is equal to R bar, be the position vectors of 2 points A comma B, where PB any point in the plane. Why? To name it. N cap is the unit vector perpendicular to the plane, and let it meets the plane at the point N. As I told, let OA bar is equal to A bar, OP bar is equal to R bar with the position vectors of 2 points, capital A comma P, where P be any point in the plane and N cap be the unit vector perpendicular to the plane. Let it meet the plane at a what point? N. So therefore, I cannot show like this, I can draw maximum like this. Now, from figure, AP bar, N cap are perpendicular to each other. Yes, we know that whenever any two vectors are said to be either perpendicular or orthogonal, the dot or a scalar product of two vectors is equal to 0. Right? Followed? So therefore, Now we wrote many times when A bar and B bar are perpendicular, A bar dot B bar is equal to 0. Nevertheless, these two are perpendicular. I can write AP bar dot N cap is equal to 0. Which implies AP bar vector is not given, its position vectors are given. How? Every vector can be expressed as position vectors of its extremities. That is OP minus OA, which implies OP bar minus OA bar dot N cap is equal to 0. OP bar minus OA bar dot N cap is equal to 0. Which implies OP bar is equal to what? R bar. OA bar is equal to what? A bar. OP bar is equal to R bar. OA bar is equal to A bar. I can write R bar minus A bar dot N cap is equal to 0. This is the required, the vector equation of a plane passing through the point A bar and perpendicular to the what? Unit vector N cap is given by R bar minus A bar dot N cap is equal to 0. R bar minus A bar dot N cap is equal to 0. This is the vector equation of a plane. Followed? So therefore, now we have come across about two planes. First one is the vector equation of a plane where N cap is perpendicular to it and P be the what? Perpendicular distance from the origin is given by R bar dot N cap is equal to P. Next, I'll go for second one. It is R bar minus A bar dot N cap is equal to P is equal to 0. This also represents a plane equation. This also represents a plane equation. Yes, when you have found out the Cartesian equation of a plane where N cap is the what? Unit vector perpendicular to it. Yes, in the same fashion, we can also find out the Cartesian equation of a plane passing through the point A bar where A bar is equal to A1i plus A2j plus A3k. And if I take N cap is equal to what? Li plus Mj plus Nk. Right? Where Lmn are the what? DCS of a unit vector. We can also find out the Cartesian equation of a plane passing through it. Followed? Right. So therefore now coming this one is, now from this, we have good applications, good in the what? Examination, good questionnaire will be there, very logical and skillful. That note, what is that note? The equation of plane, or else directly from this I can write R bar dot N cap minus A bar dot N cap is equal to 0. We know that since R bar dot N cap is equal to P. So why you are introducing this one P, I tell later. Now this is nothing but P minus A bar dot N cap is equal to 0 which implies P is equal to A bar dot n cap. This represents what? Perpendicular distance from the origin. Perpendicular distance from the origin to the plane, and that plane is passing through the point A whose position vector is A bar, and n cap be the unit vector perpendicular to the plane. For that plane, if you want to find out the what perpendicular distance, the perpendicular distance from the origin to the plane, that plane is passing through the point A bar and perpendicular to what? Unit vector n cap is given by P is equal to A bar dot n cap. So therefore, you see, very astonishing thing here is, very surprising. Always we take the dot product between what? Two vectors. Whereas in this theorem, very surprising thing you come across. A bar is a point and n cap is a unit vector. You are taking the dot product between what? The point and a unit vector. One must guess, one must understand, one must see the what logically that context. Followed. So therefore, P is the what perpendicular distance from the origin to the what plane. That plane is passing through the point A bar and perpendicular to the unit vector n cap is given by the dot product between what? Point A bar and what? Unit vector n cap. That is, P is equal to A bar dot n cap. So therefore, this is nothing but perpendicular distance. Perpendicular distance. Perpendicular distance from the origin to the plane. Passing through the point A of A bar and n cap be the perpendicular distance. Perpendicular vector to the plane. So therefore, now hereafter, so just whatever the point is given, you have to find out what? Dot product. Remember, P is equal to A bar dot n cap represents what? Perpendicular distance from the origin to the plane. Right. Thank you.